Welcome to the module on chi-square distribution. By the end of this session, you would have understood what are parametric and non-parametric tests, what is a chi-square test, what are the different situations where chi-square test can be used, and exactly how to use the chi-square test. There are many common situations where the underlying distribution is either not normal or it is unknown, or where it is not possible for the researcher to make any rigid assumptions about the shape of the population from which the samples for the study have been drawn. Statisticians have developed a class of alternative techniques to deal with such problems. These are known as non-parametric or distribution free methods. A non-parametric method may be defined as a test in which no hypothesis is made about the specific values of the parameters. On the other hand, parametric test implies that the scores or the observations should achieve either an interval or a ratio scale of measurement. Non-parametric statistics are used when the data measured are either by nominal or categorical scales, or when the underlying distributions violate the assumptions of the parametric statistics. The Greek letter chi-square was first used to describe this situation by Carl Pearson in the early 1900s. The chi-square tests are used most often to analyze such type of data which consists of counts or frequencies. The chi-square statistics are formulated basically to determine whether an observed number differs either from chance or from what was expected. Pearson has termed this as goodness of fit test to describe how well the theoretical and the observed frequencies fit the expected frequencies. The simplest chi-square design uses a single independent variable on a nominal or a categorical scale with just two levels. Let us now see what are chi-square designs. Two-cell design, which is also sometimes known as the equal probability type design, is the easiest form of the chi-square test. It is known as two-cell experiment, where the outcome of the experiment is the each event or the participant and falls in one and only one of the two cells. For example, a researcher has chosen 25 participants, 10 of whom are male and 15 are female, and wishes to know if there are significantly more females than the male participants. Assuming that the participants were chosen from a population where the number of females and males is equal, then the probability of a male participant being chosen is exactly 1/2 or 0.5, and the same holds true for a female participant. How do you deal with this problem using a chi-square test? The steps can be said as follows. First, formulate a statistical hypothesis. Next, construct a table of the observed and the expected cell frequencies. The greater the deviation between the observed and the expected frequencies, the greater is going to be the calculated chi-square value. Also, sum of the observed frequencies, that is SUM, sum of the observed frequencies must be equal to the sum of the expected frequencies. The third step is to select a significance level, which is usually termed by the Greek alphabet alpha. Next, use the table for the critical value of the chi-square. Based on the critical value and the cutoff value, make your decision and then draw the conclusion. For example, the first step, if we see, is to formulate a statistical hypothesis. H naught which is the null hypothesis, is nothing but the equality between the two probabilities. That is, probability of being a male is exactly equal to probability of being a female. H1 is the alternative hypothesis, saying the two probabilities selecting a male and a female are not same or equal. Next step is to construct a table of the observed and the expected cell frequencies. The expected cell frequencies is obtained by multiplying the cell probabilities of being a male or a female by the total number of participants in your study, that is 25 in this case. Thus, as you can see in the table, the expected cell frequencies for both the cells is 0.5 multiplied by 25, which is nothing but 12.5 each. Then we go ahead and calculate the chi-square statistic using the formula observed minus expected frequencies bracket square divided by the expected frequencies. The third step is to select a significance level alpha. The significance level is nothing but the probability value which provides us with the criteria of either rejecting the null hypothesis H0 or accepting it. Generally, 0.05 or 0.01 are used in the statistical hypothesis testing. In this example, we would be using alpha as 0.05. With this significance level, now we go ahead and use the table for the critical value of chi-square. For a particular significance level, the critical values needed for locating the rejection region depends on the degrees of freedom using the cutoff values from the table. In our case, the degrees of freedom are nothing but the number of cells minus 1. So, we have 2 cells. So, the degrees of freedom would be 2 minus 1, which is 1. Here you can see the table which has been used to find out the critical value of chi-square. The rows denote the degrees of freedom as in 1, 2, 3, 4, 5, etc., whereas the columns across denotes the level of significance alpha. As you can see in the figure, using the table we can very well find out the area which is the rejection region and the acceptance region. The yellow region in the diagram across is the acceptance region, whereas the blue one is the rejection region. If our calculated value of chi-square is greater than or equal to the critical chi-square value or the cutoff value, we are going to reject the null hypothesis. Based on this, then we give our decision. Comparing the calculated value with the critical value as given in the table comes out to be 3.84. As we can very well see, our calculated value falls clearly in the acceptance region. So, we accept the null hypothesis H0, or in other words, we retain it as it is. Then we move to the conclusion. The observed frequencies do not significantly vary from the theoretical cell frequencies beyond what might be expected by chance. Thus, we conclude that it was observed that there were more females than males in the experiment. The differences were not statistically different beyond the chance factor. Now, let us see what are the properties of a goodness of fit test. The data are usually in the form of observed frequencies. This means that there is only one data value for each category. Therefore, the degrees of freedom is 1 less than the number of categories. Secondly, whatever value you get follows a chi-square distribution. Remember, the value of the test statistic does not change even if we change the order of the categories. The chi-square test is used in two similar but distinct circumstances. Firstly, for estimating how closely an observed distribution matches with the expected distribution. This is often referred to as the goodness of fit test. Secondly, for estimating whether there is any association or relationship between two random variables. In other words, whether they are independent or dependent on each other. Let us see what is the chi-square test of independence. This is also known as the two-way chi-square test. It is used when a score is categorized on two independent dimensions. Here, the researcher is interested in knowing if the two factors are independent of each other. If they are independent, then knowing a participant's score or observation on one factor tells the researcher nothing about the participant's score on the second factor. If, on the other hand, the factors are dependent, then the knowledge about one factor can certainly help predict us the second factor. Now, let us see what do you mean by a contingency table. The table of observed and expected frequencies, as we have seen in the previous example, is often represented in the form of a 2 by 2 row and column table. Such a table is known as a contingency or a two-way frequency table. So, if we see a table which is given here, we have two categories and two data types each, which gives us a 2 by 2 table. The cell first row first column is usually denoted by small alphabet A. First row second column is usually denoted by alphabet B. Second row first column is denoted by the alphabet C, whereas second row second column value is denoted by the alphabet D. The row totals then can be represented as A plus B and C plus D respectively, whereas the column totals can be given as A plus C and B plus D respectively. Remember, the grand total of all the four values is nothing but the total frequency capital N. The columns symbolized by C represent one categorization into which the subjects may be placed. On the other hand, the row symbolized by R is nothing but the second type of categorization for the same response. It is called as a contingency table because here we are trying to find out the probability of dependence or independence of one variable on the other. To recap the steps used in calculating a goodness of fit test with the chi-square distribution can be given as: first, establish your null and alternative hypothesis, that is H0 and H1. Calculate the chi-square statistic. Assess the significance level which you would like to use. Finally, based on the cutoff value, decide whether to accept or reject the null hypothesis. Let us summarize the entire module. Parametric statistical tests are based on the assumption that the samples come from the populations that are normally distributed. Here, the level of measurement for the parametric tests is assumed to be either interval or at least ordinal. On the other hand, non-parametric statistical procedures are designed for ordinal or nominal data and are distribution free. In these tests, no hypothesis is made about specific value of the population parameters. The chi-square test is a statistical test used to examine differences with categorical variables. The discrepancy between the observed and the expected frequencies is the subject of the chi-square test of significance. Remember, the chi-square test can be used in two similar but distinct circumstances. The goodness of fit test is mostly used for a single dimension data, whereas the test of association is used when we have two dimensions. Hope this module has given you a good idea about the chi-square distribution and the related chi-square tests. Thank you.